Great. Good afternoon, and thanks for coming back after lunch to continue the conversation. So I've been actually with AWS in Canberra now for over 6 years, and one of the consistent themes that I've seen from talking to my customers in that time is a real interest in where we're at on sort of local compliance and security matters, and getting advice on how customers can build secure applications in AWS. And so I'm excited to be here today to talk about one of those controls that you can put in place to secure your applications. I'll be talking about the AWS Key Management Service and how you can use that to encrypt data at rest and to enable secure workloads. So I'm going to go through a fairly simple agenda here with some key takeaways. So the first, I'm going to give a bit of background on where we're at with our IRAP compliance process here locally, and then talk about one of the services that's been highlighted in our latest Stage 2 IRAP report for enabling secure and protected workloads, and that's the AWS Key Management Service. And to do that, I'll give a little bit of background into encryption concepts, and then dive down into KMS. And then to try and make that sort of real for you is I'll go through a bit of a walkthrough of a fairly simple application, just a standard sort of web stack, but to actually show you in practice how you'd apply KMS to implement encryption at rest pervasively across that architecture. So let's get started. So first of all, let's have a look at the IRAP process and where we're up to. So we've actually been through multiple IRAP assessments here locally in Canberra, and have been listed on the ASD CCSL now for a number of years. So when we started in that process, we started off simple, as Amazon often does, sort of in a sort of MVP mode with the core infrastructure services and at the unclassified DLM level. But actually this year, early this year, we took a big step forward in this space, where we've undertaken an IRAP assessment at the protected level on a much broader range of services. So we've completed our Stage 2 IRAP report at the protected level, and that's now available to you to download at any time through your existing AWS account through one of our services called AWS Artifact. So it's a self-service, one of our services that you can go to and download all of our compliance documentation. That covers 46 services in scope, and one of the key things in that report is that it recommends the use of KMS particularly for protected workloads. And the reason we've made this report available to customers, of course, is to be in alignment with DTA's Secure Cloud Strategy, which highlights the ability for agencies to self-certify workloads. So you can take this information and leverage that as part of that process. And of course, we're continuing to work with the Australian Signals Directorate and the Cyber Centre to get these services listed on the CCSL at the protected level. And if you need more detail on timelines in that process, I'd direct you to those agencies. So what are these 46 services that I've mentioned here? So this is a list that I'm showing the services that were in scope of that assessment. And you can see here that it's quite a step up from the traditional just infrastructure-focused ones that we initially went through the certification on. So we've now expanded into a broad range of service categories. So things like big data, analytics services, desktop as a service offerings, application streaming, managed database services, so RDS, DynamoDB, those types of areas. But also services to help you manage, update servers, patching, those types of areas in the management space. And a number of services to help you in building applications, so services that will be of high interest to developers and people building distributed solutions. And also a number of security services to help make sure your infrastructure is secured and well maintained within the AWS environment. In addition, in the sort of traditional areas around compute, storage, and networking and so on, the range of services even within those categories is quite expanded. So for example, in compute, it's not just about virtual machines as a service with EC2 now, but we've got things like container services with Docker support and serverless with Lambda. Now, one of the services that was highlighted in the IRAP report to help with using all of those services was the AWS Key Management Service. So this is a service we introduced actually way back in 2014. So it's been around for quite some time now. It's been through several iterations and additional features. And this was highlighted in the protected Stage 2 IRAP report as an enabling control that you should use on all services that it integrates with when you want to do say a protected workload. And what KMS gives you the ability to do is very simply enable encryption at rest for storage and other services in a very straightforward manner. So you can literally, with something like a simple storage service, hit a checkbox, select a key, and you know that you've enabled encryption at rest of all the data in that bucket, for example. What KMS then also does and allows you to do behind the scenes is things like manage the keys, their life cycle, control who gets access to those keys, what operations they can do on those keys, and so on. You can do things like enforce rotation of keys and manage a life cycle. Things that are traditionally been quite difficult to do in a sort of enterprise key management system, trying to take that sort of undifferentiated heavy lifting away from you and provide it as a service. We give you visibility on how this service is being used, so you can see through some of our logging tools exactly how, when it's being used for encryption, when it's being used for decryption, and so on. And you can also use things like our config rules, which I'll talk to later, to actually say, have continuous compliance understanding, do you have encryption enabled across your architecture? So I thought I'd help you understand where it's been integrated across those 46 services that were in scope of the IRAP assessment here. So this is the same list that I showed before, but what I've done here is highlight those that have some form of KMS integration. So it's in green, or if you can't see the colour, I've got an asterisk by the service. So you can see here it's a pretty pervasive list that there is some form of KMS integration. So in the storage services, that means you can hit a checkbox, get encryption at rest very easily. For some of the streaming services, that means you can enable encryption using KMS as data is being streamed. And it's also integrated with a number of the sort of logging and monitoring services. Now, before I go into sort of details on KMS, I want to give a little bit of a primer around encryption. And so what we're looking at here is symmetric-based encryption and sort of encryption at rest scenarios and controls. So typically, if you've got some data, you've got some hardware, you might have some sort of algorithm that you want to apply to do some encryption at rest operation. So you need a key to then apply that algorithm. So you'll then apply that key and that algorithm to some plain text, and then you'll end up with some ciphertext, so that's unreadable by yourselves or your adversaries. And that means you can then store that encrypted ciphertext in your storage of choice, knowing that it's secure and in an encrypted form. But of course, there's the question then is, well, what about that data key that I use to encrypt that data? Where do I put that? In a traditional world, that might have been, in an offline sort of scenario, lock it in a safe or write it on a notepad, hopefully not stuck underneath your laptop or something. But you had to decide where that's going to be kept, and that's where this sort of building a key management system starts to get quite complex. So how do you do that in a sort of cloud, high-scale, hyperscale environment? So one of the common techniques here is to use what's often referred to as envelope-based encryption. So essentially what it means is that you have another key, say we're calling here a master key, or in the case of KMS, we call it the customer master key, because you can generate one or many of these keys. And we use that key then to encrypt that data key. And so then what that means, you can then take that encrypted data key and store that with your encrypted ciphertext both they're in a secure form with encryption at rest applied. But of course, you might then be wondering, hang on, what about that master key? Where do I put that? And so that's a good question. And then a potential answer there is, of course, well, we can have another key and we'll encrypt that. And that'll be safe then. And then the question is, well, what about that key? And we'll have another key, so we'll encrypt that. And so you can see here, there's some sort of key hierarchy that you need to put in place. And at the top of that hierarchy, you typically end up at a point where you need some sort of secure location for a key at rest. And that's often, say, where people start talking about things like hardware security modules, for example. So when people are evaluating a key management and encryption solution, these are some of the questions you may be sort of running through your mind. So you want to know where these keys are actually being stored. Is it on something you control? Is it single tenant, multi-tenant? Is it hardware you own? Is it on premises or in the cloud provider and so on? Where are the keys? How are they being used? Are they only used in your software, your client software, or are they used in a service, for example? And can you control how those keys are used? Give permission-based access to them. And then, of course, you want to have some sort of a level of assurance around that those controls are actually being put in place. So let's touch on a few of these sort of points as we look at how KMS actually works. So this is a picture showing how the sort of KMS service operates. So it uses, like I said before, like there's some sort of hierarchy involved. And so in this case, we have this two-tier hierarchy. So at the top of this diagram, you have the KMS service. And you can interact with that to generate what's called these customer master keys. So you can create as many of these as you like, and then importantly, you can control who can use those keys and what they can do with them. What you then do is then, when you actually want to use either via an AWS service or even your own application, actually perform some data encryption operations, you don't use that customer master key directly, you use that key as part of the generation and encryption of those data, what's called the data keys. And these can then be sent to the services securely and then leveraged to do the actual bulk encryption operations locally at the service itself. So this helps in limiting the blast radius of encryption to a single service or a single application of your own. It also helps with the performance of encryption operations because they can be performed locally and close to the data. It's also easier to scale the KMS service because you're managing just a smaller number of customer master keys rather than potentially, say, millions of data keys, for example. It also it sets up this centralized audit and control point where KMS, so for you to get access to those data keys in a plain text form, you have to go back to the KMS service to request it to decrypt those keys. So that's an opportunity for you to authenticate and authorize those operations and log those operations. So it gives you that very tight control on how these keys are used. So with that sort of introduction on the sort of components within KMS and how they're used, I'll step through now an actual API call and to show you how this actually works in practice. So this is how, here on the orange box here represents either, say, an AWS service, so that could be EBS block storage or S3, the S3 service, or it could even be your own application if you've written something to leverage the KMS APIs and our SDKs. And then we've got the KMS service where we've assumed here you've created a customer master key and put some permissions on who can make use of that. So the first thing, when that service, it's got some data and it wants to encrypt that data. So what it needs to do then, it makes a call out to the KMS service. Now that's an API call with AWS, so as with all of our APIs, it's authenticated and authorized. So you have to be authenticated, you have to be authorized to use that KMS service. Now assuming that's the case, that'll succeed, and KMS then will use your customer master key. It'll generate a data key, encrypt it with that master key, and it'll return back to the service to the data key in two forms, one in the plain text form and the other in the encrypted with the customer master key. Now, importantly, the customer master key never leaves the KMS service, it's staying in that hardware security module. So that service then, or your application, can use the plain text copy of that data key. And when we implement that in our services, we never store that data key on persistent media. It's only stored in memory. And that's used then to encrypt your data. By that, so if that was S3, encrypts the data, then can store that data encrypted at rest, and then disposes of that plain text data key, and then also stores the encrypted data key with your data. So what that means is that later on, when say you need that service to decrypt that data for you, or that application to decrypt it, it actually has to call back to KMS to retrieve the plain text data key. So it'll send the encrypted data key back to KMS. It'll use the customer master key to decrypt that and send it back to the service. So you can see how this provides that sort of separation of duties and also that single point of control. So what are some of the sort of assurances that we put in place to make sure you can rely on KMS as a key part of your sort of security infrastructure here? So one of the technical things about the internals of KMS is that there is no actual tools or APIs in place to extract those customer master keys. So there's certainly no public API that you'll see on the KMS API, and there's in fact no internal ones either, so you can't extract those customer master keys. You can actually import your own keys, that's a new feature of KMS, but there's no extraction mechanism. Like I said, the plain text keys, they're only ever stored in non-volatile memory, so they're never persisted to disk, so they're not going to sort of lie around for someone to pick up. This integrates tightly with our identity and access management service, so you control exactly who's allowed to administer and create keys. You can also control about who's allowed to use those keys and for what operations. So you could have separate people allowed to encrypt versus separate people decrypt, for example. This allows you to start setting up that sort of typical separation of duties type models where, say, for example, even your system administrators or server administrators, you may not give them permission to access the key material to do decryption operations. And that might be a separate, say, a cipher control group that gets that access. So it's very helpful in those situations where you want to say even the administrators can't get access to encrypted data. And on our side, we also put in place a number of multi-party controls for some of the sensitive maintenance operations. So there's actually a white paper I'll put on a link to that in a later slide that talks about some of the controls that we put in place. And by multi-party controls, I mean where two people actually have to agree to perform some sort of operation. And so that's a bit like if you remember back to the 50s and 60s where you might have seen people in the missile silos each had to put a key in the console to launch a missile. And that's the kind of degree of rigor we're going to with this service. So it's great that I say we do all these sort of controls, but how do you actually know that we do those controls? And so that's where our audit and compliance program is really important. Where you can get a variety of independent third-party analysis of this service to know that it does what it says it does. So the first one of those is that IRAP protected report. So like I said, that's available on AWS Artifact. You can download that and read through that document. But there's also a wealth of other literature you can actually drill down to in this space. So FIPS, which is a US standard for encryption, actually goes through our hardware security module. So that's another document you can download, gives you a lot of detail of how KMS is constructed. And interestingly, it's one of the few examples where you can see a picture of a device that's in one of our data centers because it actually has a photo of the hardware security module there. So if you like seeing photos of stuff, that's a great document to have a look at. Also in the US, the FedRAMP program, which is the equivalent program for US government, for cloud service providers. Again, KMS is in scope, a key service in that. And areas for healthcare. So if you're interested in healthcare information and protecting that type of data, You might have heard of a thing called HIPAA. Again, it's one of the services that is in scope of that certification. And also, of course, the sort of usual internationally recognised things like ISO programs, SOC compliance, and so on. And even things like PCI, which is around handling credit card information and personal data around that. Again, KMS is one of the key services used there for encrypting that sort of data. So I've talked about, giving you an update of the IRAP program, where we're at in that, talked about encryption and the KMS service. Let's actually apply that now to an example application. So what I'm taking here is a pretty simple sort of application for AWS. So if you've read any of our architecture documents or seen a standard web stack, this will be really familiar to you. So it's just a standard web stack. It's web servers at the front end behind a load balancer with using our relational database service in the back end. Across what we call two availability zones. So you've got high availability running in a virtual private cloud. So very standard web stack, and I'll step through how you can apply KMS to that. I've also got down the bottom there an S3 bucket. So you might use S3 in a web stack, for example, to store static content. So your images, your client-side JavaScript and so on, you offload that from your web servers to reduce load and so on. You might also use that S3 bucket for things like backup of your servers and also as a location to drop logs from those servers, for example. So centralized logging location. So we'll step through all of these components now and apply KMS across this architecture. So at the front here, the web tier. So the web tier is using our virtual machine as a service offering called Amazon EC2, and that uses a service called EBS Elastic Block Store for the disk drives that are running with that server. Now EBS directly supports KMS, and so what that means for both data and boot volumes, you can go into the console like I've shown here in a little, I've just cut out part of the console relevant to KMS. You can see there you can just hit a checkbox, and importantly then also select what customer master key you're using for this. And then once you've done that, your data is being encrypted at rest by the EBS service. For boot volumes, there's a little bit of extra steps you go through. You create what's called an Amazon machine image. But again, once you've set that up, it's again encrypted at rest using KMS and the EBS service. Now I've shown there how you do it in the console. At the bottom of the slide then I've also shown you can also do this in the CLI, so via command line tools, so that you don't have to just do this hunt and peck in a console. You can start scripting this, automating it to be a bit more reliable. So that's how you might want to do this at scale in a more automated fashion. So that's the web tier. So let's drop down now to the database tier. So in this case, I've used one of our managed database services called RDS, so Relational Database Service. So this is where we're running the database for you, so you don't have to sort of install, patch, and manage the database. But again, we're leveraging EBS storage, EC2 under the covers, and we've integrated this with KMS. So again, you can just go to the console, hit a checkbox, or in this case, a radio button, and then again, importantly, choose that customer master key. So that's a key that you manage, you control the lifecycle of. And once you've done that, the database is encrypted at rest using KMS, and even also the logs coming out of that database and any snapshots to back up that database. And then even that S3 content, remember I said we could also use S3 for that static content, maybe your images, your client-side JavaScript, so on. Also your logs, your backups of this application. So again, S3 integrates very straightforwardly with KMS. And in fact, one of the newer features with S3 is this concept of what we can have turn on default encryption. So if you turn that on for a bucket, all objects then within that bucket are encrypted, again with that customer master key of your choice being used to generate and control the data keys. So here I've shown how we can very straightforwardly, essentially just hitting a few checkboxes, and that entire architecture now has encryption at rest controls implemented across that quite broadly. And so if in a traditional world that might be the end of the story, you do an audit, certification, and off you go. But we can actually take this even further in an environment like AWS, where everything's an API, everything's logged and monitored continuously. So one of our other services is a service called AWS Config, and this gives you a configuration view of your environment over time and how it changes over time. So it tells you exactly what resources are in your account, what they're related to, say what disk drives are connected to what servers, etc., etc. You can then take this further with config and set up rules to say if various points of compliance go out of compliance, trigger an alarm. And so we've got a number of built-in rules here, including the ones I've put on the slide here that are relevant in this space. So we can enable a rule to say, if my RDS databases are not encrypted, trigger an alarm. If my EBS volumes are not encrypted, trigger an alarm. If my S3 bucket's not encrypted at rest, trigger an alarm. Now that can be, the alarm could be as simple as send someone an email, so the administrator knows they need to do something. But it can also be an automated event, so that it generates an event. That can be picked up, say, via a Lambda function or some other bit of code, and then actually do some remediation of that environment for you automatically. So you move to this continuous compliance posture. Now KMS, then once it's applied, it integrates with our Identity and Access Management service, which is our service to control who can do what within your environment. So this means you can start getting very fine-grained around how people can use these keys. So you can have different people that are allowed to administer keys versus who can use the keys for encryption, decryption operations. You can even have separate applications that are allowed to encrypt versus decrypt and so on. You can then you can control where they're allowed to come from. So maybe you want to say only from my corporate IP range to use these APIs. One of the sort of common tasks within a key management system is around rotation of keys. So this is one of the things that's often done, and there's often quite a bit of admin overhead in doing this. So again, we've tried to make this as simple as possible for you. So you can simply hit a checkbox, say rotate this key, and it will do that every year. It'll keep the old key so you can decrypt old data, but then new data is encrypted with that new key. Our audit and logging tools give you the ability to know exactly what's going on within your environment. So one of our services is called AWS CloudTrail. If you turn that on, you get an audit log of every API call that's processed in your environment, and that includes any calls to KMS. So in this example here, you're seeing that there's events, someone's trying to use the decrypt operation. You can see that they're doing it at a particular time. They're doing it with a particular key identifier. And then in this case, they're doing this on an EBS volume. And you're even seeing where they're trying to do it from, so the source address. And then who they claim to be. So again, you can use this information to set up logging and monitoring and an alarm. So if you see an API coming from, say, an IP address that it shouldn't be coming from, trigger an alarm or trigger some sort of remediation. And then we can tie this in with some of our automation services to even help you take this even further and apply this as in a very templated fashion. So for example, our AWS CloudFormation service allows you to build, say, that whole web stack via just a single JSON script, which means, and as a part of that, then you can enable KMS in the fashion that you want it to be compliant in your organization. So then you can use it as a template to stamp out in dev, test, and prod, knowing they're identical, or across multiple sort of business lines, so that you know everyone's deploying it in a compliant fashion. You can then take that CloudFormation template and drop it into a service called Service Catalog, which allows you to offer these as like standard service offerings within your organization. And then if you're looking at multiple account sort of structures, which is very common in sort of enterprise environments like government, where you want to have multiple accounts, AWS accounts for different business units or environments, that also includes the ability to, say, enable things like those config rules to enforce the use of, say, KMS within each account as required. So just in summary, I really went, there was sort of 3 key points there. I gave you a status on where we're at with our IRAP process. Encourage you to have a look at our Stage 2 IRAP report at the protected level that enables agencies to self-certify today. I've talked about encryption and how KMS is one of the key services in this space. And then I've demonstrated how to actually use that in a common workload. I've got some resources here I encourage you to have a look at. If you want to dive down into the details of how KMS actually works under the covers, look at that first paper, the cryptographic details one. That goes into a lot of those multi-party controls that we do on our side, the security of the cloud. But if you're more interested in how you should build your solution securely, have a look at the best practices white paper. And then just to finish off, I want to encourage, if you use these QR codes, encourage you to give feedback. We want to use that to improve these sessions for future summits. So thank you for your time.